For Faraday's Law Lab, we're going to use the Fizzlet here to take a look at the flux versus time and what's happening. Okay, so for the first part here, what is the fluxes at time 1 and 3 seconds? When we let this run here, okay, you can tell that you've got this flux versus time, and then you can pause it and find what it is at that 2 seconds or 1 second. It's 1 second and 3 seconds, not 2 seconds. Okay, and you can always restart it and it'll do the same thing over. Okay, just a side note I want to point out here, notice that we do have a negative flux that is decreasing to 0, but we also have a negative, current and a negative voltage. So all of these are given in negatives, but we can either account for those or use those absolute values. Okay, but just be careful when you're doing the change in flux when you're looking at these, okay? So once again, you're getting your, try to get as close as possible. When you click on this, the 2 yellow numbers are your XY coordinates. So you want to get right around 1 second and then go to 3 seconds. And then you can find your change in flux over time, okay? And then we're going to calculate our induced EMF and then take a look at this area here. So this is where I've been getting a few questions, okay? First of all, our speed is given to us. It is 1 meter per second. When we click on this grid, as always, we are getting the X and Y coordinates. This is in meters, so maybe not the most realistic since this is a huge 20 meter or over 20 meter rod here. What you want to do is look at the area inside this rectangle here. And when you're getting the length of the rod, we're not going end to end, but more where this rod is in the area. Okay, so I would kind of go to this corner here, and I've got a Y coordinate of 10.7 in the positive direction. And then down here, I've got about 10.7 or 10.8 in the negative direction, right? Because the 0 is right in the middle here somewhere. So you can figure out the length of that as well as the area. All right, so when you're looking at the change in area, you can, it doesn't specify exactly what it is, so you can do for 1 second if you want, or you could just time it. So if I were to start here and then stop, I know I've got a time of about 1.42, okay, and then it moved to 4.3 in the X, and then this is my other X over here, negative 10.5, okay, and where it had started at 5.7 in the positive direction, so you can look at that change in area here, all right? So we're actually calculating our length times width, and the change in area, and then that change in time. So if you're wanting to do it for exactly 1 second, you have to figure out where this is going to be after 1 second, okay? So that's how we're finding this change in area here over time. And please actually do find the change in area over time, because then the next question is you're going to be looking at the length of the rod, and we're going to figure out this little relationship here, or we're proving this little relationship here, okay? So then you can go back and use your information that we got here. So your flux at any given point in time with that particular area. You can find your B, and same thing here, that length of the rod times the velocity, and you already have our EMF, and you can compare your calculated magnetic fields. Okay, similarly right here, we're gonna take a look. This is our equation from last week, and then remembering that our current is charge over time, we can derive this equation here, which is F is equal to ILB. And you can calculate your applied force and then go back and find your force. Okay, hope that helps with this lab. Please reach out if you have any questions.